Okay, last video before I switch back over to my college videos for a little bit. So we got vertical angles. The vertical angles are special. They are angles formed when two lines intersect. And they are always across from one another. Why are they important? Because vertical angles are congruent. So if I were up here and I labeled this angle A, and I labeled this angle B, and I labeled this angle C, and I labeled this angle D, angle A and angle C are vertical. Meaning angle A is congruent to angle C. Angle B and angle D are also vertical, which means angle B is congruent to angle D. Okay, so you kind of treat these like these ones that would be with the midpoint and the bisector. They're across from each other, so they are in fact equal to each other. So they are across from each other, so I'm going to set them equal to each other. So I subtract, and I get, subtract again. Again, remember, you can throw your line down like that if you want to, just to help you keep things, know when you have to go across the side and do the opposite. But 23 minus 5 is, so that's 18. Divide by 2, x equals 9. Now this time I'm not requiring that we actually put it back in, but you could put it back in, and these should be exactly the same measure when it comes out. And then, same thing here, these are directly across. Don't let the name fool you. I know vertical implies that you would go up and down instead of left to right. Because vertical is up and down, horizontal is left and right, you know, how the sun races horizontally. But vertical is just a name. They're just names for those that are across from each other. Anytime they're across from each other like this, we are going to set them equal to each other and then solve. And I've gotten students who've asked me, you know, which one should you do first? Should you do the x or should you do the number? Doesn't really matter. It's going to come out to be the exact same answer regardless. Regardless of how you do it, you're going to get x equals 10. So most of my students are looking for a formula. Not everything's formulaic, and actually shouldn't be formulaic, but that's what it is. Okay, so vertical angles, all you're doing is just setting them equal to each other and solving. As long as they're across from each other, they're equal to each other. What gets a little bit tough is when you realize that when you have vertical angles, you don't necessarily have just that relationship there. Because not only do you have vertical angles that are across from each other, but you also have angles that are directly next to each other, which we call adjacent angles. So, adjacent angles are angles that are next to each other. So, angles that are next to each other. So, how does that happen? What's going to happen here? Well, if I look at this situation down here, I still know that this is 27 degrees because they are equal to each other. But what I don't know is what's y and z. I know y and z have to be the same thing because they're vertical. Just like x and 27 have to be the same thing because they're vertical. But I don't know without something else what y and z is. But we do have something else. If we look back at the last lesson, well, if I look specifically at x and y are together and they form a straight line. That means that x and y are a linear pair. And what did we talk about before with linear pairs? Well, all linear pairs are supplementary. So what that means for vertical angles, at least, is adjacent angles with vertical angles are supplementary. They're linear pairs. So what I get here is that x plus y has to be equal to 180. But I know what x is. X is 27. So all I have to do is do 27 plus y equals 180. And then solve. Subtract 27. So let's see. 3 and 5. 153. So that makes y 153. And by default, that makes z 153. Okay. So now we can get a little bit more complicated here. And this is what I call a nice fun case to look at. Keep your wits about you and you'll be able to do this. Ready? So once again, I have 7x plus 15. I have 2z plus 12. I have 5x plus 25. I have 5z minus 15. Now, by virtue of being vertical angles, I know that this is true. I know that the angles across from each other are equal. But you might be saying, but doesn't that mean that these are equal as well? And my answer to that is yes, they are equal. But how's that going to help you? Y and z? It's just two different variables. Can't help you right now. Nothing you can do about that. Well, I can solve this one at least, so let's solve it. Yeah, you can never, ever, ever solve an equation with two variables unless there's two equations to it back to back. It's called a system of equations. And we don't really deal with a lot of system of equations here in geometry. It's more of an algebra 2 thing, which I'll talk about when I start talking about all of that. But that gives me x equals 5. Now what can I do? Even though I'm not technically looking for measures of angles, I can actually put 5 back in and get 7 times 5 plus 15. And so that's 35 plus 15, which makes 50. Now, we'll check it just to be sure, but this should also be 50 since we said that these two have to be the same. So, 5 times 5 plus 25, well, hot dog, it's 50, which proves that they're the same thing. We did it correctly. But how does this help us find what y and z is? Well, it turns out I don't have to do this at all. Because if I know this is 50, if I use the thing I just learned that adjacent angles and vertical angles are supplementary, well, then these two have to add up to be 180. Well, I know this one is 50. So that means, what is the supplement of 50? 130. They have to add up to be 180, right? And then by process of being vertical, this also has to be 130. Because remember, angles across from each other have to be equal to each other. So 5y minus 15 equals 130. 2z plus 12 equals 130. This is kind of time when I start telling my students they need to kind of do the solving the equations themselves. So I think I'm just going to solve this one real fast in my head. I got 145 and 145 divided by 5. Let's see. That would be 29. And then let's see, 130 minus 12 is 118. 118 divided by 2, 59. No. Yes, 59. I'll double check it. I'm fairly certain that's what it is. Yeah, okay. So, that's my two answers there. Now I'll do one more of those real fast in a second. But I want to take a look at this guy here. So, I want to find out what x is. X is right here. Now, automatically when I look at this, I say, well, these are vertical, right? So these have to be equal to each other. So whatever this angle is, this angle is. And then I look and I see, hey, look, there's a right angle here. So that must mean that this angle here and this angle here have to add up to be 90. So that means that x has to be 53. Okay, so let's look at one more of these type of angles. Now this next one's going to be slightly different. We're going to have to put our thinking caps on for this one. Ready? Oh wait, no, I lied. This one's actually pretty same. The next one I'm going to do is actually slightly different. But it's going to have the same idea here. Ready? So, we got 3x plus 29, we got 5x plus 17, we got 9y minus 2, and we got 6z plus 7. So once again, you could put 9y minus 2 equal to 6z plus 7. They're vertical and you can do that, but it wouldn't help you because you can't solve something with two variables in it. So what we're going to do is we're going to do 3x plus 29 equals 5z. Whoop, 5x. I don't know why I said z. 5x plus 17. Then I'm going to subtract. And I'm going to subtract. Again, if you need to, throw that little line down there to help you out so you know how to keep it on the steady. X equals 6. Another thing that my students don't really like very much is when you put the x on the right side. There's no static place the x has to go. The x can be on the right, it can be on the left. It doesn't really matter. Okay, so now it wants me to find AEB, and it wants me to find CED, which is these two right here, which is what I pretty much already found. I found the x equals 6. So I'm going to do 3 times 6 plus 29. So let's see, that's 18 plus 29, which is, let's see, 9 plus 8 is 7, 47. Okay, and then just to check, we would have 5 times 6 plus 17, which is 47 as well. So that means this is 47, and this is 47. Okay, then... since I know this is 47, again, that rule about adjacent angles falls into play. This forms a straight line. Therefore, this angle here is 180 minus 47. So it's 180 minus 47. It forms a straight line. If it forms a straight line, they're supplementary. So I'm going to get, let's see, 133. Yep, that would be a supplement, and this would also be 133. So I know now that both of these are 133. So 9y minus 2 equals 133. 6z plus 7 equals 133. So I'm going to add 2. So let's see. 9 into 133, so it would be 1... or not 133, 135 is what I should say. So 9 into 135 should be, let's see, 13 minus 9 is 45. So 9 and 45 would be 5, so it should be 15. And then minus 7, 6. So that would make z 21. And that would be the whole thing pulled out. Okay, so what happens when it's just a slightly different thing? Well, let's look at one of these real fast. I'm not going to look at this one. This one's just kind of the same thing that it's been. So is this one. So I'm actually going to jump to this one over here. It brings up my kind of slightly different situation that occurs here. And that is, what happens when the x's aren't across from each other? They're directly next to each other. So technically speaking, 9x plus 12 does in fact equal 9z plus 3. That is a perfectly valid equation. So is 8x plus 15 equals 16y plus 7. Also a perfectly valid equation. Neither one of these will get you anywhere because you're going to end up with an x equal to a z and an x equal to a y. So when you look at this, you have to logically figure out what is the equation that's going to just focus on the x's. And you have to remember that the adjacent angles have to be supplementary. So instead of doing these two, again, they're perfectly valid equations that you could set up that will lead you to absolutely nowhere. You want to set up the fact that these would add up to be 180. They're supplementary. They're next to each other and they form a straight line. So I want to set up this idea. And I do that because it's got all the x's in there. There's not two different variables now. So it's going to be something I can actually solve. 9x and 8x make 17x. 15 and 12 make 27. So I'm going to subtract 27. And I get 153, and then I divide by 17. And 17s aren't really a thing that I keep memorized off the top of my head. Now, if I think about it, 24. This one scares me a bit because it seems like it's not going to come out to be solid, but it has to be, I think. Wait a minute. What can I multiply 7 by to end in a 3? Not 5, not 6, not 7, not 8, 9 maybe? This would be 63, right? Does that make sense? Let's see. 7 times 9 is 63. 9. Oh, it is. It's 9. X equals 9. You can check that with your calculator if you want to, but it should work. But then I'm going to go back up here and say 8 times 9 plus 15 and 9 times 9 plus 12. And this is going to give us a different kind of check because these aren't vertical, so they're not going to be equal to each other, but they should add up to be 180. So 8 times 9 is 72. 72 plus 15 is 87. 9 times 9 is 81. 81 plus 12 is 93. And if I do the quick math in my head, 93 and 87, they would add up to be 180. So that means that they are good. FOW is 87. And WOX, which is the bottom one, XOW, it's the same thing, but backwards, is 93. Well, here's the thing. Again, this is where vertical angles come into play. If I know this angle is 87, then the angle across from it also 87. So COX is 87. If I know that this angle is 93, then the angle across from it has to be 93. They're vertical angles, so this is also 93. Okay? Well, that also means that I now can figure out what y and z are, because I can do 16y plus 7 equals 87, and I can do 9z plus 3 equals 93. And if I do the quick math, let's see, that would be 87 minus 7 is 80, and then 80 divided by 16, so it would be 5, because 5 times 16 is 80. And then, let's see, 93 minus 3 is 90. That one's easy. 9 divided by 9 is 10. That gives me the answers that I want. So, just remember, if they're across from each other, you set them equal to each other. If they're next to each other, in vertical angles at least, if they're next to each other, you add them up to be 180.